now with inequalities.
Okay.
What? Oh, yeah. And so it's the one that I'm on is,
Can you solve that one right there?
yeah, x is less than 15.
How about this one here?
Negative x is less than 15.
Solve it for x.
Yeah, and then I don't know actually.
Well, you need to divide both sides by a -1, right?
Mm-hmm.
Okay. Well, the only difference between equalities and equations is that when you divide both sides or multiply both sides by a negative number, you have to turn the inequality sign around.
Uh-huh.
So it becomes x is greater than -15. In other words, I still have to divide both sides by -1, but then I turn that in the other direction. And that's really the only difference between inequalities and equations. So what's your first problem?
H minus, and then parentheses, -2 is is greater than or equal to 10.
Okay. Solve that.
First we have to get, so it's going to be x times 2 is greater than or equal to 10.
Hold on. There's no multiplication going on here unless I misheard you. You said h minus a -2, right?
Yeah, so it's h plus 2.
Right. So that becomes this. But
So it's h.
don't confuse addition and subtraction with multiplication and division. You just got to always keep those straight. So h is what?
H is greater than or equal to 8.
Okay, cool. How about another one?
Now I'm working with creating inequalities.
Okay.
A number x minus 3 is at least -5.
Well, if it's at least -5, then it has to be that, right?
Mm-hmm.
In other words, you have to, now you got to come up with the inequality, right?
Yeah, and then I have to solve it.
And that's what that means, is that x minus 3 is at least -5, means it's greater than or equal to -5.
So it's x is greater than or equal to -2.
Right. And you talked about graphing these?
Yeah.
And you graph them on a single line chart. It's not the XY plane, which we're more used to. It's a single line chart. We'd go to our point, -2, closed dot or open
filled
dot?
in circle. Filled in.
Filled in, closed dot. And then it goes to the right with an arrow, like that. Okay. What else?
6 is less than or equal to the sum of a number z and 15.
So tell me how I can write that.
6 is less than or equal to z times 15.
Well, read the words again to me.
The sum of a number z plus and 15.
So what does that mean? Does that mean z?
Addition.
That means z times 15? Or
addition, I think.
Z plus 15.
Plus.
Right. Now, what's the next step?
Then I go minus 15 minus 15.
Okay. So what's the next line?
It's going to be...
What's 6 minus?
9 is less than or equal to z.
It's minus 9.
Oh, yeah.
6 minus 15. Always remember that if you're subtracting a bigger number from a smaller number and they're both positive, the answer's got to be negative.
You were flying on a plane. Your
Hold on.
carry-on bag can weigh...
Hold on.
Oh.
Let's not be done with this problem yet. If I wanted to put z on the left side, what would the rest of it be?
Z is greater or equal to -9.
Yeah, and that's all you have to do. In other words, if you want to switch the variable and the number, just switch the direction of the sign, and that takes care of it.
Mm-hmm.
And a lot of people with inequalities are not comfortable with that variable on the right side. It's not quite the same as equations. But the equations, you're just as comfortable with the variable being on the right side as you are the left. It doesn't matter, really.
Uh-huh.
But with inequalities, most people generally like to keep the variable on the left side, or at least put it there when they're done.
Okay.
All right. What's the next one?
It is, you are flying on a plane. Your carry-on bag can weigh no more than 50 pounds. Your bag weighs 38.
Okay.
It's going to be...
What's the question?
You are flying on a... Oh, write and solve an inequality that represents how much weight you can add to your bag.
Okay. So let's define a variable here. Let's let W equal the weight of your bag. Well, they told you it was 38 pounds, right?
Your carry-on bag can weigh no more than 50 pounds. Your bag weighs 38 pounds, yeah.
So we know that that's 38. The weight of the bag is 38.
Mm-hmm.
So what can I write?
In
terms of, well, let me think about this.
38. Yeah. Wait, I just did this problem, but differently. Let me look at my notes.
Tell me how you did it, because I'm having a little bit of trouble figuring out the best way to word it.
It's going to be 38.
Ah, I hear it.
38 is 38 plus
our problem the problem with the way I did it was I didn't make the variable correct. Let's let x equal the amount you can add.
Yeah. So it's going to be
give me an inequality.
38 plus x is greater than or equal to 50.
Got to be less than or
less than, sorry.
It's okay, but it's very important. They're not the same. In other words, once you add, in other words, you could add 12 pounds, right? You solve this, you get never any reason to change anything. So you get 12 pounds is how much you can add to the weight of your bag. Okay? This was actually an excellent illustration of how important it is to define your variable properly. In other words, I defined the variable as the weight of the bag, which was a mistake. They gave us that number. That wasn't a variable. We didn't need that. What they were asking was how much could you add to the bag. So that's what we want the variable to be, is the amount you can add. Almost every single algebra word problem, you can go to the last sentence and it will tell you exactly how to define your variables. Okay? This problem, they were asking you how much can you add. Well, that's what you should make your variable, how much you can add.
Uh-huh.
All right. What else you got?
Can you add a 9-pound laptop and a 5-pound pair of boots to the bag without going over the limit? No, you cannot.
Correct. That's 14 pounds.
Describe and correct the error in solving the inequality or graphing the solution. -17 is less than x minus 14.
Okay, let's first solve.
-7. Wait, no. I have to describe the error, so I have to tell you the thing that they told me to do. Okay. So it's going to be negative 17 plus 14 is less than x minus negative 14 plus 14.
Okay, that's correct. So that's minus 17 plus 14. That's what they said?
Uh-huh.
Is less than x minus 14 plus 14. In other words, all I did was add 14 to both sides. Okay. What's
negative 3 is less than x.
That looks correct.
Okay, now there's a graph.
Okay, now whenever
Negative
there's only
3.
one variable, it's always a line graph.
Oh, no, I know where it is. I know where the problem is. They went the wrong direction. They went left instead of right, going right.
Well, right, because they got the variable on the wrong side, right? It's confusing.
Yeah.
When that variable is on the right side in an inequality, it tends to be confusing. So if I turn it around, I get x is greater than minus 3, which clearly means I got to go to the right.
Mm-hmm.
But that's what this says also, notice. If you read it right to left, it says x is greater than minus 3. Says the same exact thing as that does. You don't even have to memorize any special rules. But
okay, negative 10 plus x is greater than or equal to negative 9. Negative 10 plus 10 plus x is greater than or equal to negative 9.
Okay, what's the next line? Tell me what to write.
Negative 10 plus 10 plus x is greater than or equal to negative 9.
Plus 10.
But yeah, negative 10 plus 10.
In other words, if you're going to add 10 to both sides, you got to add it to both sides. Like
yeah.
And
well, I'm reading what the problem is.
What's that?
I have to solve the error.
Oh, I get it. Okay. So what did they?
I'm not reading to you what I would solve it by. I'm reading to a solve.
Kind of hate these problems, but that's okay. So what did they do next? They did minus 10 plus 10.
Plus x is greater than or equal to negative 9.
Okay, so what did they do wrong?
They did not add 10 on both sides.
Correct.
All right, yeah.
Okay, what else? Do they want you to properly solve it?
Yeah.
Okay, so if I added 10 on both sides, what do I get?
You got x is greater than or equal to 1.
Correct. Okay.
Hold on. Okay. Which of the following inequalities are equivalent to the inequality x minus b is less than 3, or b is a constant?
Okay, what are your choices?
X minus b minus 3 is less than 0.
Is that true?
Let me think.
How'd they get to this step?
No, it's not correct.
How did they get to this step?
They subtracted 3 from both sides.
Is there any problem with doing that?
No. Actually, there is, yeah.
So that is correct. What other answer did they give you?
0 is greater than b minus x plus 3.
Notice that that's exactly the same thing. In other words, they took this, which we know to be correct, and they just switched everything.
No, they didn't, because it's adding 3 instead of a subtraction.
Right, but you got to switch the sign. In other words, if I say 0, let me take an example here. Let's say I tell you that minus 2 is less than 0. True statement or not?
It is not a true statement. I mean, it is.
It
Sorry.
is, but if I want to put the 0 on the left side, then I do this. And you're right. I don't do anything to that. I don't switch the signs. So you're absolutely correct. This is not correct. They switched the signs. In other words, they put the 0 on the other side and switched that, but this should read exactly the same as that should read. X minus b minus 3. And you'll notice this is the exact opposite. In other words, that is technically this. It's minus x minus b minus 3. That's what it is. And that's what the answer should be, only what that comes out to be is this. I'm sorry. I apologize. Hold on. You do not put that negative sign there. Those two are equivalent. This one, if you can see where I'm pointing, number 1 is equivalent to number 2. In other words, is all I did is switch them. It's like the associative property almost.
So they are similar.
Well, no, because the one you gave me had a negative sign here, a plus sign there, and a plus sign there. So it was not. It's got to be exactly the same. It's got to be x minus b minus 3. Or it could be x minus 3 minus b. These can be in any order, but you can't have different signs on the problems. What were their other choices?
X is less than 3 minus b.
Is that true just based on that one?
Yes. No, it is not.
No, it'd be, I'd have to add b to both sides, so it would have to be that. And what's another choice?
Negative 3 is less than b minus x. It is true. Right.
Well, let's bring both the b and the x to the left. So that means minus b plus x minus 3 is less than 0, right? In other words, taking that number 2 and merely manipulating it. Well, is that the same as that?
No.
Actually, it is. The sign on the x term is the same. The sign on the b term is the same. And the sign on the 3 is the same. So this one is the same as 1, and that's the same as your original. In other words, the associative property holds here. I can rearrange these. Since I'm doing nothing but addition and subtraction, I can merely rewrite these. I can put the x first, still have a minus in front of the b, and I still have a minus in front of the 3. So I haven't done anything between step 3 and step 4. So all I've done is rearrange them. Well, now, step 4 looks exactly the same as step 1, which we already decided was the same as the original. Which means 3 is also the same as the original. So always remember that you can rearrange some stuff. It's just like a times b is the same as b times a. Well, a plus b is the same as b plus a also. Okay, what else?
Okay. Is it possible to check all the numbers in the solution set of an inequality? When you solve the inequality x minus 11 is greater than or equal to negative 3, which numbers can you check to verify your solution?
Negative 3?
Yeah.
Okay. Well, first of all, what's the answer? Let's solve for x.
x is greater than or equal to 8.
Okay. Now, can you check all of the possible numbers? Not really.
No.
There's an infinite number of numbers. I mean, the numbers go to negative infinity and positive infinity. So for me to check every single number is impossible. Okay. Which numbers can you check? Does it give you a multiple choice?
No.
Well, I don't know how to answer that. I think that's a bad question, to be honest. In other words, I guess I can check all the numbers. Now that I think about it, let's see, is minus 100 work?
No.
Does plus 100 work?
No.
Well, plus 100 does. It's all
yeah.
greater than or equal to 8.
I was thinking 8.
Does minus 200 work?
No.
Does 8 work?
Yes.
Yeah. So I could check all the numbers, but from a practical point of view, you really can't, right? So yeah. I'm not quite sure what they're asking there, to be honest. But the most important thing is to be able to solve it to get that. In other words, once you know x is greater than or equal to 8, you know how to graph it. You know what numbers x can be. They got to be greater than or equal to 8. It's pretty straightforward. Okay, what else?
Write and solve an equality to find the possible values of x. Perimeter is less than 51.3 inches.
Okay.
It is the triangle. On the base, it is 15.5 inches. The height is 14.2 inches, and the oh god, I forgot the term.
Base is 15.5. The vertical height, which is the height they're talking about, always the vertical height.
And then the other one is x inches.
What's the other one?
Well, when they have it, it's a...
Is it the line on the right or the line on the left? The slanted line, or?
They don't have any slant, they don't have a 90-degree angle there, but they don't have any, they don't have a, it looks like a right triangle.
Oh, I bet it's like this. I'll bet the vertical height is not what they meant.
Yeah.
I'll bet one side is that.
Yeah, one side. That's what I meant.
That's 14.2.
Yeah.
So
and then the other side is x.
What can we say about x? First of all, we know what? Give me an inequality that applies to this model, to that picture, and that right there.
Well, an inequality.
So what can I say?
X is less than...
Let's add up the three sides of the triangle. That has to be less than 51.3, correct? Okay, so x plus 14.2 plus 15.5 has to be less than 51.3, which is the perimeter. And now we can solve that pretty easily, because now that means x plus 29.7 is less than 51.3, which means x is less than 21.6 if my math is correct.
Yeah.
And so that progression is the way you want to look at all these problems, is what kind of an equation can I write, or an inequality as the case is here. In other words, can I write an inequality and solve for x? And that's what we did. We based the inequality on this picture that I've circled. We know that the sum of the three sides of this triangle is less than the perimeter, and they're telling us the perimeter is less than 51.3. Then just solve it. Solve it for x, and you get your answer.
Mm-hmm.
All right, what else?
It's the same thing, but it's kind of harder. It has four sides, but it's not a square. So just, can you draw a random four-sided?
Yeah, quadrilateral.
Yeah, and the side on the left is 4.9 feet. Side on the top is 4.1 feet. Side on the right is x feet. And the side on the bottom is 6.4 feet.
And the perimeter is what?
Perimeter is less than or equal to 18.7 feet.
So give me an inequality that applies to this model.
X plus 4.1 plus 4.9 plus 6.4 is less than 18.7.
Okay, solve that for x. Do it in two steps. Add those three numbers together first.
For one thing, the two numbers
add to
15.4. 15.4.
Good. Now what?
Subtract 15.4 from both sides. X is less than.
That's the only thing that has to be true, is that side has to be less than 3.3 to satisfy this perimeter condition.
Uh-huh.
Right.
And I'm done with homework.
Okay.
She gave us only one-sided this today.
Okay. How about we spend 10 minutes on A plus math, and I'll let you off for 45 minutes.
Okay.
Does that sound all right?
Yeah.
Okay. In fact, I'll tell you what. You don't have a calculator, right?
I do not.
Okay. We'll go until you get 10 in a row.
Okay.
Begin.
0. 0.
No, I got to get my keyboard in front of me. That's
3.
1. That's 2.
-7.
That's 3.
30.
That's 4.
-11.
That's 5. Oh, it's counting. I don't need to count out loud. It's showing me on the right.
10. Yeah.
Ooh, that's close. You almost wanted to say -10, huh?
-2.
Good. 7.
Oh, God. I'm going to take my time on this one.
Good.
12.
Good. It's 8.
-15.
Okay, one more and I'll let you go. Ooh, a toughie.
Oh, no. Can I do one guess before you type it in? -5.
Very good. Now, next time when we do this, I'm going to put a time requirement. I'm going to say, we'll go until you do 10 in a row, but you got to get the 10 in a row under a certain amount of time, okay?
That's going to be -2, by the way.
Well, that's fine. Now, I'm happy that you got all 10 of them correct. And it's helpful that I can see which ones give you difficulty. We'll work on those. That one gave you some difficulty. Just put those two negative signs together, so that's really -6 plus 1.
Uh-huh.
Okay, and that's what you did. So, all right. That's all we need to do for today. I don't normally like to cut sessions short because a student ran out of homework, because that kind of promotes them not having homework. I mean, you know what I'm saying? So I'm sure your dad would probably say, just do an hour regardless of whether he runs out of stuff or not. But there is a certain amount to be accomplished by having goals and prizes and rewards. And you just got 10 in a row, so I'll let you go this time tonight.
Okay.
Okay?
Okay.
All right, Logan. I'll talk to you next week.
Bye.
Bye-bye.